This video is over topic 20, finding margin of error and confidence intervals. We are specifically doing 95% confidence interval. We have a formula for the margin of error that is specific to the 95%. If you go on Google, if you talk to a tutor, if you ask somebody how to find a margin of error, how to find a confidence interval, you will not find the formula we're using. You will find things that are way more complicated. There'll be P's, there'll be Q's, there'll be standard deviation and mean and all sorts of things. Don't do it. What you need to know when you see anything that's to do with a survey, you have a number of people that responded and you have a survey result percentage. That's your cue to use this. Also, if it says the words margin of error and if it says the words confidence interval, you'll use this. So what you are doing is the margin of error is this formula. This is what you have on the course formula sheet that you'll have available on a test. What you need to know about this, the plus or minus isn't part of your calculation. Take that as a reminder that the margin of error gets both added and subtracted to something. The 100 means the result is a percentage. So it's already doing the percent conversion built into the formula. The n is the sample size. So you're told how many people responded or how many people were surveyed. That's n. So 100 divided by square root of n. The confidence interval is two numbers. It's a least and a greatest. We are taking a survey result percentage that says the people that answered the survey, 25% of them gave this answer. I want to talk about everybody, not just the people that took the survey. I cannot say 25% about everybody, but I can spread it out a little bit and say maybe somewhere between 20 and 30%, right? So that's a confidence interval. There's a between, there's a low end and a high end. The low end and the high end are equal distances from the actual survey result. That distance that they are from the survey result is the margin of error. So you calculate the low end point by taking the survey percentage minus the margin of error. High end point, survey percentage plus the margin of error. You do not do any calculations with the 95%. You do not do any calculations that combine the percentage with the sample size directly. So you do not need to find how many people gave that response. So let's take a look at a practice question. So there's more like examples and stuff. Read that on your own time. But we have this example. After spring break, a university newspaper puts out a survey of where students went on spring break. 271 people responded. 31% went to Florida. 32% stayed home. So what is the 95% margin of error? Again, I am not doing any calculation with 95%. The 95% is quantifying how confident I'm going to be. So margin of error, when I see this, I need to know to use the 100 divided by square root of n. And in this case is the 271 people that responded. So I'm doing 100 divided by square root of 271. Make sure that you can do that on your calculator. So 100 on this calculator, I have to put the 271 and then the square root. You can probably do the square root and then the 271. Make sure on whatever calculator you are using that you can get this answer. 100 divided by square root of 271 is 6.0745, etc. We will round that to the nearest tenth of a percent. It's already a percentage. So 6.1% for our margin of error. Then sometimes you'll be asked for like a whole confidence interval. More often you'll be asked like separately, what's the low end, what's the high end. So we can be 95% confident that at least what percent of all students went to Florida. What that is asking for is I take the Florida percent of those surveyed, exactly 31% said they went to Florida. To talk about all students, I need to say, well, it could have been as low as the margin of error below that. So 31 minus 6.1 is 24.9. So I'm 95% confident. I'm pretty sure at least 24.9% of all students went to Florida. The highest percentage for the 95% confidence interval would be 31 plus 6.1. So that's 37.1. So let's say I make myself a little diagram here and I'm going 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 9. So the actual the percentage of just the survey responses was 31. The confidence interval says, all right, that was those that actually responded. If I was able to talk to everybody, it might be anywhere down here, anywhere all the way down to 24.9, or could be up here, anywhere up to 37.1. So the actual percentage of everybody could be anywhere within that range. Now, what's the 95% confidence interval for students who stayed home? Now it's just asking for the confidence interval. I need both low end. So at least this and at most this. So we're going to take students who stayed home was 32%. So I take 32 minus 6.1, which is 25.9, and 32 plus 6.1, which is 38.1. So here we would have 32 as the survey result for those that stayed home. But if I was able to talk to everybody, it could be below that. It could be down here, 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 anywhere, all the way down to 25.9, or it could be above that, anywhere in here, all the way up to 38.1. So is it valid to say more students stayed home over spring break than went to Florida? Of those who responded to the survey, sure. Of everybody, I can't be sure of that because we have any of these possibilities, a lot of these possibilities for those that stayed at home could end up below the possibilities for those who went to Florida. So no, the overlap of the confidence intervals means more could have gone to Florida. Okay. If we had a much smaller confidence interval, so let's say our margin of error was like 0.4. And so then my intervals would be like these real tiny little intervals to where the home interval is fully above. There's actually a little gap between them. Then we could say, yeah, we're pretty sure, still only 95% sure. There's still a little chance, but we're 95% sure that more people stayed home than went to Florida. So that's margin of error and confidence interval.